Determination of protein nitrogen in flour by using the KJELDAHL method. In this practice, the nitrogen content and protein percentage in a flour sample will be determined. The main steps involved in the KJELDAHL method are as follows. First, flour samples are properly weighed. Then, the sample digestion step is carried out using boiling concentrated sulfuric acid and a catalyst. In this step, all the organic nitrogen is converted to ammonium ions. Next, the previous ammonium ion solution is made basic using sodium hydroxide, leading to the formation of ammonia, which by steam distillation is collected into an extract of boric acid. Finally, the acid-base titration of the resultant borate ion is carried out using sulfuric acid and an indicator in the acidic range, and the nitrogen content present in the flour sample is quantified. The samples, reagents, and solutions used for this practice include a commercial flour sample, KJELDAHL catalyst tablets and sodium carbonate, a 2% boric acid solution, and a 0.03 molar sulfuric acid standard solution, and a 0-to-0 indicator solution. Additionally, a 40% sodium hydroxide solution that, as the boric acid solution is already prepared, is required. Sample digestion. For the flour sample analysis, 1 gram of flour sample is approximately weighed with the help of a spatula using polystyrene weighing indices and an analytical balance. A total of 6 sample replicates will be prepared by recording the exact weight of each of them. To perform the sample digestion, KJELDAHL catalyst tablets, mainly containing selenium, potassium sulfate, and copper sulfate pentahydrate, are required. Thus, with the help of a spatula, 1 catalyst tablet is introduced into each KJELDAHL flask to favor the digestion step by increasing the boiling point of the sulfuric acid as an oxidant and thus the temperature of the sample oxidation process, as well as by catalyzing the reactions. Next, the flour sample is carefully introduced, ensuring the wall contained falls to the bottom of the KJELDAHL flask, followed by 12 milliliters of concentrated sulfuric acid previously measured in a graduated cylinder. A total of 8 KJELDAHL flasks, including 6 sample replicates and 2 blanks, but in the absence of flour sample, are placed in the digestion module. The digestion is carried out for 60 minutes at 410 Celsius degrees. The resulting fumes from the process are collected through the upper module and neutralized using a 15% of sodium hydroxide solution. During this step, the organic matter is carbonized and turned into a clear yellow liquid. At this moment, the digestion module is removed from the digestion unit, separating the KJELDAHL flasks from the rest of the equipment to let them cool down. Sample distillation. To carry out the ammonia distillation, an Erlenmeyer flask containing 50 milliliters of 2% boric acid solution and the adequate volume of the 0-to-0 indicator is placed in the distillation unit. Then, and once the digestion process has been successfully concluded, each KJELDAHL flask is placed in the distillation module. To do so, the plastic tube is introduced and then the blue handle is pulled down to fix the flask in the device. Subsequently, the distillation process is started. At this moment, the device automatically adds water and 18 milliliters of a 40% sodium hydroxide solution to neutralize the ammonium ions formed during the digestion process. The released ammonia is then distilled by steam distillation and trapped in the boric acid solution, thus producing borate ions and a color change of the indicator from violet to green. Sulfuric acid standardization. The titration of the generated borate ions is carried out with a 0.03 molar sulfuric acid solution, which must be previously standardized with a primary standard substance such as sodium carbonate. To carry out the standardization process of the sulfuric acid, from 100 to 125 milligrams of sodium carbonate are accurately weighed on an analytical balance and dissolved in 50 milliliters of the ionized water, making sure that the whole primary standard substance is transferred to the Erlenmeyer flask to be properly dissolved. Subsequently, the 0-tau high-quality acid-base indicator, which is made by mixing 2 drops of methyl red solution and 1 drop of methylene blue solution, is added to the Erlenmeyer flask containing the sodium carbonate solution. This pH indicator solution is suitable for the pH range from 4.4 to 6.2. The resulting solution is then titrated by adding a small volume aliquots of the previously standardized sulfuric acid solution from the burette to the Erlenmeyer flask by shaking the solution until the 0-tau indicator turns from green to violet color. The sulfuric acid solution standardization process allows calculating the accurate concentration of the prepared solution, which will then be used for titrating both the samples and the blanks. Next, the solution is boiled for 2 minutes to remove the generated carbon dioxide, observing as the violet color of the solution changes back to the initial green color, according to Le Chatelier principle, by removing one of the products of the titration reaction, a further reaction shift towards products formation is achieved. After cooling the flask, the titration is resumed until the violet color is observed again, so the titration has finished. Sample titration. The last step consists of titrating the borate ions formed after the distillation process for the 6 sample replicates and the 2 blanks. To do so, the previously standardized sulfuric acid solution will be used as the titran reagent and, by following the same procedure, small volume aliquots of the standardized sulfuric acid solution are added from the burette to the Erlenmeyer flask until the 0-tau indicator turns from green to violet color. By knowing both the exact concentration and the volume of the sulfuric acid that has been consumed in the titration reaction, the protein nitrogen content of the flour sample can be determined. Since the nitrogen content must be calculated using the dried sample mass, it is necessary to determine the humidity content of the flower sample. For this purpose, 3 completely dry and labeled porcelain capsules are weighed on an analytical balance, recording the exact weight of each of the capsules. Then, with the help of a spatula, approximately 1 gram of the commercial flower sample is weighed into each capsule and the exact mass is recorded. Next, the capsules are placed in the oven at 130 Celsius degrees for at least 90 minutes. Once the drying stage has concluded, the capsules are cooled in a desiccator until room temperature. Finally, tempered capsules are weighed again with the help of oven tongs. This process is repeated until successive weighting agree to within a certain value, usually 0.5 milligrams, meaning that the flower sample has been dried to constant mass.